part, look into the deviation of the machine parameters. If pressure, flow is okay or not, vibration, okay or not, is there any change or not, temperature, is there any change or not. For that, either you can feel it visually, either or you cannot do it, then instruments you use, or if you cannot do it, different type of parameters have different instruments, and accordingly condition monitoring techniques also develop different way. If it is vibration, so we take a vibration instrument and its procedure systems, you call it vibration monitoring systems. If you take temperature or thermal imaging, you take as a sensing part, then you analysis part, and entire system you make it thermal imaging system, different condition monitoring technique. So ultimate certain selected parameters we measure. Why you measure? Because we want to know the deviation from the acceptable levels. Once you measure, you can then only you can see the deviation. So deviation from the acceptable level. Why you want to do that? Because present and future health of that particular asset we want to know. That particular equipment we want to know what is the present health and what is going to happen in future. That's what all about condition monitoring. That's all. Monitoring condition. That's all about the condition monitoring. So there are lot many things available, latest technology, because it is better to predict. Instead of opening the palms bearing at certain time, which we call a time-based maintenance, schedule maintenance, that is called preventive maintenance. Okay, that is time-based. Instead of opening certain things unnecessarily when it is good, it is better to predict. कुछ हो रहा है कि नहीं, अंदर देखता हूं कोई इंस्ट्रूमेंट लेके, अगर कुछ प्रॉब्लम है तब खोलो उसको, अदरवाइज मत खोलो बियरिंग को. अगर कुछ प्रॉब्लम नहीं लग रहा है, नॉइज नहीं लग रहा है, वाइब्रेशन नहीं लग रहा है, क्यों खोलना है? नहीं, 6 मंथ पहले उसको हम मेंटेनेंस के लिए टाइम दिया तो खोलना ही है एज पर द रूल्स. देयर आर मेनी इंडस्ट्री लाइक दैट, not required. That's why prediction has come into effect, and that's why you call it condition monitoring or condition based maintenance, predictive maintenance, because you are predicting same thing. Okay, and taking decision based on the condition monitoring or diagnostic engineering, call it. Okay, so by diagnostic tools. Okay, so these are the called condition monitoring. These are very vast. Condition monitoring, vibration energy, we have just giving you a idea of what is all about. Otherwise, these are all separate techniques. 1 week training also just for condition monitoring possible. 1 week. Okay, vibration monitoring 2-3 days, 4 days training is possible depending on the level of depth of exposure needed for the participants. Okay, so there are many techniques based on the different type of parameter: oil, vibration, oil analysis, wear debris analysis. Okay, ferrography we call it. Okay, so there are techniques are there. There is dedicated instruments, structure, all the things are there. All what are all these things? This is all for maintaining the equipment the right way, so that our energy consumption less, our productivity also increases. So for thinking productivity for all those things, but right now we have to think, or some people are already thinking right now, and there is a possibility that is already case studies are available where people have used this and got energy saving. Right, that's why I want to give you a little bit idea on this. Okay, so different vibration, this is thermal image, this is thermal image. There's a lot of possibility. Okay, energy consumption study, prediction of failure, detection of failure, all the things you can do. Means you are doing maintaining the machine the best way, because you know the oil before the failure, much ahead of it. And you can take a sudden failure will cost 15 to 20% more, maybe sometimes some critical cases 50% more than if you got some problem, open it and see what is happening the problem, accordingly change the bearing or the parts responsible for the problem, then it will be much less maintenance cost. Okay, so, and why you want to study this? Because we cannot avoid this 30% increase next 5 years in CBM market, condition monitoring diagnostic market. Okay, and because of the industry 4, IoT, ML, everywhere people are talking about, so how predictive maintenance is going to help us in your diagnostics of these assets is important to consider. That's why you want to know this. You cannot avoid that. Education training very vital, which you are doing either industry, institute combined, or separately industry or separately in institute. That's education and training we do. There's a lot of possibility, research, PhD, MS programs on this field. Okay, so there are a lot of topics available. So who are interested, you can guide them, not an issue. So renowned institutes are available in India who are dedicated in this line. Okay, pretty, and industry requirement is from 20-30% what is available right now. And many industry already crossed 30-35% in petrochemical refinery I've seen in Gulf. Okay, in some one or two company here in India. But most of the Indian company, this is very in preventive maintenance, time-based zone. We have to go to higher zone of asset maintaining the asset to get maximum benefit out of it. Chahe energy ho, chahe production ho, whatever. And we need an integrated way of approach. So while you're talking reliability, availability, what is it all about? Reliability means, am I reliable for this lecture? Or are the participants reliable? I mean, are they listening properly? Are they getting benefit out of it? Is there an interesting better way? Means reliability means fitness for the purpose. That particular purpose. What is the fitness? Okay, what is the fitness for the particular purpose? Continuing fitness for the purpose. Sorry, fitness for the purpose is the quality. That's it. And continuing fitness for the purpose is the reliability. So when you think about purchasing something, think about reliability, not the quality. Reliability takes care of the quality. Quality with time is the reliability. And if you take a good definition, then reliability means there is ability. There is uncertainty into it. And what is uncertainty? Means always less than 100%. It can never be 100%. Let it be any space research or whatever missile. It can never feel that 100% correct. No, there is always failures, and that failure will be 0.1%, something like that, whatever. So reliability picture, the probability has come into picture. That's why it is ability you're talking. Probability of happening something for a particular timing. That means let us take a good definition. Okay, probability of an item or product or equipment so that it runs users requirements time in the particular environment operating condition, maybe harsh environment, pura dhul pada hai. Okay, and that environment, okay, particular time, so that its mission time is completed. This is the way reliability is. What is the probability? Because there is always less than 100, 90% reliability. Probability of success 90%. Probability of failure and reliability, okay, maybe 1%, 2%, depending on the equipment assets. Okay. So what do you know about reliability right now? Continuing fitness for the purpose, just thought process. That's all, nothing else. This is everything about the reliability definition. You study 10, 15 definition from different books, all will be saying like this. If they're not saying, I think we are not making justice to the ORM. Okay, reliability. So it is predictability. It is less than 100%. Okay, there is uncertainty. Then only we'll talk reliability, other is not. If there is no uncertainty, there is nothing reliability talk. There is no statistic into it. Okay, so availability is what? Out of 24 hours, how much hours this machine is available? If it is 20 hours, then 20 out of 24 is the availability. And how you get 20 or 19 or 21? It is all about speed. You maintain this machine. That means it is maintenance related issues. If you maintain a machine, pump, it takes 1 day for one worker or two workers. Okay, 1 day, but it's supposed to take say 1.5 days. Then its availability of this machine is will be higher. What I meant to say, how if you take less time, availability of the machine will be higher, because you are adding unavailable time to the available time. Okay, so availability, there is formula, study, other thing, reliability. We don't want to go into deep into this, because this is will take a lot of time, because our idea is now cost saving. So we not go, but idea we should know this. Maintainability, there is total difference in maintenance and maintainability. Maintenance is the task you are doing it, and maintainability is design concept. Maintainability. So if I tell how I can repair this, it is easily maintainable. But if I tell the equipment, say computer, laptop, I cannot maintain it easily. So maintainability of this PC or laptop is very low, and this is very high maintainability. We can maintain it. So pump maintainability is higher than the turbine internal maintenance. So ease of maintenance is the issue. How easily we can maintain a machine. If this thinking has come into your mind, then you understand maintainability. So maintainability any equipment is not maintenance. Maintenance is the task. Maintainability, how you cannot do? You cannot do anything wrong or right in increase or decrease. Everything done in the design. Same way in the PC also, everything done in the design. We have no other choice except major modification. So we cannot do it. So maintainability more or less cannot be changed except in design. So that's the thing, design issue. When we talk reliability class, that time we'll talk about it. So this is the bathtub car, we all know all. Initially any machine fail with infant mortality, and first failure is high, then over the time it decreases, then it has a random failure, constant failure quite a long time, and after that we are out failure aging process. This is equally good for the human, it is for the asset also. Okay, and there are certain things we are in maintenance. Certain maintenance issue, we restrict consequence. Vibration monitoring, consequence. Non-destructive testing, consequence. Failure pattern has started. We have no other things. We cannot stop that. Only thing, कब टूटेगा वाइब्रेशन, अच्छा कब बेरिंग फेल होगा, और ये देखते 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 हमको 1-2 महीना में चला आएगा कि नहीं. Okay, that is the thing. We are consequence monitoring we are doing, and chance, there should not be any chance. If you look into that, that means we have to look into the design and that way of whatever thought process people have here put it, those things, proactive maintenance type of things to do. So why and different type of techniques is given, whether you are measuring or you are interested to go into maintenance in consequence way or in chance way, which is good that you have to look into this. Okay, so there are cost reduction techniques, a consequence reduction, and there are chance reduction. And in the entire asset, all the asset will go through performance curves. See, different type of maintenance. If you maintain initial machine, then over the time, vibration, ultrasonics, all the things in this PF integer, potential to failure, PF curve it is called, for any machine is importance. So till it's back down. Okay, so asset condition in installation like this, and precision maintenance, lesser alignment, other things you do properly, then your machine will run without any much problem longer. In curve will go like this. Properly aligned machine means less energy consumption. So this is the thought process of maintenance. Like these visual monitorings are there, just like endoscopy in our body we do. So visual monitorings are there. Okay, and visual monitoring of turbine part, internal part. Thermal imaging, we just take temperature of the machine and it looks like this. This is thermal image, this is normal image, and we connect. There is technology issue, instrumentation, no time to discuss and all this, just gives an thermal imaging. You might have seen thermal imaging nowadays for corona in different airport. Okay, all thermal imaging only, and the same technique, same thing is going on. So here high temperature you can find out, and that is after correction low temperature you will get the low temperature 51. Earlier it was high 105. This is the white means 105, 1046. So that's the different way, mechanical application, all the application bearing, there is maintenance techniques, right? These things, if you do all in time, it will save your energy. This motor is running like this. If you keep on like this, it is taking more energy by way of heating, by way of misalignment, bearing damage, and all the things. It is taking more energy. If you count it, you don't count. That's why कुछ नहीं होता है, क्या आता है, चल रहा है 5 दिन से चल रहा है, change कर देंगे. No, if you count it, and number of motor in the industry, such a 1,000 motor, 2,000 motors are working in different plants for the pumps and for other fans, then you'll see what is the energy it will go close. So there are different thermal imaging has been done in different places. Transformer, you see hotspot here and disconnected. After that, if you type, this is the original picture and it is thermal image. Okay, transformer. Oil analysis is a fluorography. You take oil, then you take the oil for properties testing, and you take the oil for machine condition. How we come to know the machine condition? The oil visited certain places inside the machine. All those machines को कुछ wear particle है कि नहीं है, तो fluid में आ जाएगा, liquid में, and that we test in a laboratory and we get analysis. So this is also a very vast subject, just for giving you oil debris analysis or ferrography called. Most of the ferrous particles, so its name is given beginningly ferrography, but non-ferrous particle also get captured and we analyze. So you start from, suppose it's gearbox. Pattern analysis is important. Suppose it's gearbox. You start from here, then collection of the oil. After you prepare a ferrogram. This is a ferrogram method, like slides or blood test. Then you do put the oil from top. Here you put drop by drop, and all the particle will be captured here, and it will look large large particle will be in the beginning, small particle is here, like this it will flow, and particle will be captured. How it will capture? There is a magnet under it. All these under this magnet is there. This is two simultaneously going on. This is like, so these things you get it, and after that the same thing, this slide we seen under the microscope, scanning electron microscope. We call it in industry ferroscope because the name is given like that. Okay, and after that we get the picture like this. So different type of particle will give you different type of symbols, and from this symbol, from where this particle is coming, knowing the equipment design, its parts, its component, we can find bearing. बेयरिंग है तो निकल कुछ नहीं आ रहा है ना, सेफ्ट ऐसा है, वो सोच के हमको ये सब देखना है. So skilled people are doing, there are many people are there, industry available, everything available, so things are there. I not go much on this. This is, looks like a paragram. And NDT, there are no number of non-destructive testing, radiography, ultrasonic, acoustic, diamond, the number of tests that are available for maintenance, that is maintenance. So anything parts, say what furnace cell temperature is ranging, getting, it should be below 25-30 or maybe 60 or 70 degrees centigrade, but we are getting in certain place there are 300 degrees centigrade inside temperature, 1400-1500 electric arc furnace of the steel plant. So that much temperature, but in certain place you're getting more. That means energy is going past, plus this may have a hole afterwards. After sometimes we have to capture that by thermal imaging. Then when you correct it by NDT, other thing, we can correct it and you get the availability of the machine, and you get energy saving also. So these techniques are very much helpful. Magnetic particles also, they are magnetic. These are magnets. These magnets are used for particle. If there is some flaw, that flaw will create separate eddies, and that eddy you look like this, and you can get, and over the time when you do it, you spray a liquid along with the liquid or sometimes dry powder. Then powder we put and put this magnet, energize it, and you get the shape wherever the shape like this, wherever you have a fault, and you get the magnetic, by magnetic particle testings, we get the fault scenario, where is the fault, surface fault, and the surface fault will appear like this. And accordingly, if you cannot visualize properly, you can put some spray, colorful, and the dye, and you will get this clear idea. And take a photograph, you can see what is given. So things are available. Magnetic particle, we will not go detail. Radiography, just like our X-ray. Here you use more on gamma ray in industry. So here in less exposure machine and like this, in X-ray also we take in industry for advanced technology for maintenance. Okay, acoustic emission, pressure vessel, anything happening, anything creep going on. Creep you cannot see. So if you put the sensor, acoustic emission sensor, piezoelectric accelerometer, then you take different places and you will see different distance. You can find out what is the real time problem is happening over the months, years from this asset, which you are in doubtful, you think doubtful or important, critical. So the other thing available. Vibration is very common use. You use vibration monitoring in different equipment and different points. Every point there are three each horizontal, vertical, axial will take vibration. Why you take in 3 direction? Because vibration has got 6 degrees of freedom, and all the 3 direction you have to take. Okay, and from this vibration, for every type of fault, there is different type of characteristics. Misalignment separate, unbalance separate. Accordingly, you analyze and you get the different. There is online system also vibration. There is on by analyzer also. So we take it system. All turbine, compressor, large compressor having this. Okay, so we get online diagnostics. So these are unbalance issues, like this one case, different places in a steel plant. So there is a unbalance and looseness both combined. This looks like this. I'm not going to discuss here on condition monitoring or diagnostic, but advanced maintenance tools are available to maintain the equipment that helps energy required. So critical asset motor energy saving 30 to 80% of total industry globally, if you see. And life cycle costing 92% energy consumption itself. Okay, 5% on capital, 3% exclusive maintenance, and 90% in energy consumption. This motor, if it is not maintained, I think this is only this is maintenance cost, labor, other thing is done, spare other things. This energy much more can be reduced if you take proper electrical unbalance should not be there. Okay, eccentric gap should not be there. Bearing both the point of the motor should run properly. It should not be eccentric. There are a lot many motors we have seen eccentric in the bearing, and it gets a lot of energy more than what is supposed to take. Old motors, rewinding is common. अरे motor खराब हो गया, winding करके ले आओ. More rewind, more energy consumption for that motor, because every time there are human errors. You cannot wind the motor the way it was in the factory when it was shipped to you. So that is possible. So in large motor, about 20%, 18% large motor winding cost of rewinding, and 88% of the initial cost. Rewinding is done old motors. That is very dangerous for the energy savers. Like you can detect these problems by vibration analysis. 70-80% motor problems you can find out. You can find a motor current signature analysis, or MCA, or PD, partial discharge, power quality, all the things you can do. There are a lot many techniques, other techniques are available in motor energy saving. Motor energy saving by VFD, there must be some caution. We use always very easily variable frequency dive, and you change the speed, and we are getting a lot of energy. But in that process, we damage the also bearing, because there is a high peak voltage available, and while very fast pickup, very fast down, very sudden change in RPM, all the things happening, and takes a lot of energy. And in that there is always spark through the bearing. If bearing is not insulated, this bearing will damage. You will create extra problem while taking VFD also into consideration. So what is the solution? There are solutions. These are the things happening in the bearing, common for all VFDs. But are the people are taking, or they're just putting a VFD on the previous setup? Then there will be a big problem. They must earth properly, and bearing damage, electro discharge machining should not be there within the bearing. So in the bearing, which is supposed to run properly, concentric way, is now running machining. It is machining. Discharge, electric discharge machining is going on inside the bearing. Very tough problem, very serious problem. So things you have to, by insulating the bearing or earthing, it should be done. Now latest motor, if you purchase VFD, question them how it will better it is insulated. If insulated, what insulated material is taken? Is the casing is the separate material, or the bearing is the material? Will create a interaction and capacitance other issues or not? Check. You have to check it. So that is the thing. So you need to have judicious mixing of your thinking, putting in VFD. See, in VFD, fixed speed pump like this, and VFD this, we save this much, but this much saved should not create my motor itself problem. If motor, some HT motor, 1 megawatt, 2 megawatt, like this, plenty in power plant, mainly in steel plant and process plant, 1 megawatt machine, because of bearing damage and entire shaft broken, it will be crores of rupees production loss. So while saving energy here by VFD, you may damage the entire machine. We have to be cautious a little bit. So depends on, there are many things, depends on flow control, energy saving, different that we have discussed in pumps also last page, whoever attended. So there is a flow control. You can control the flow, you can save the energy. Okay, performance curves of the driven machine, all the driven machine, pump, compressor, anywhere, all the energy savings, how performance of the driven machine is. That's the ultimate criteria for energy more or less in the driver. If driver is the motor, then motor has to take consideration the driven machine's behavior. That means its pressure, flow, temperature, vibration, all the things to be taken care. So that's what performance curve of the driven machine. And system resistance it has to encounter. This motor, what type of system resistance a pump is encountering every time, every minute, has to be taken into consideration, because the system curves remain unchanged, but your performance curves will change depending on the performance. So that's the way energy saving possible on the different thing. So how big is the potential? In the potential of the pump, is it too much? That day also I told you, 800 pump manufactured here, 18 billions worth, 16-18% growth in pumps, and all pumps everywhere in industry, IPMA, all things, industry is full of pumps. There is potential of saving too much, and it is not saving. How will save it? Maintain it properly, operate it properly. That is the only saving. If you cannot do, no VFD, no other thing will going to have a energy saving at all. This is VFD also it is a timing. If you want to take, suppose you take a next project, think how many places you have put the VFD. So then the next project I will obsolete the VFD. I will take a right size palm, right size driver for the particular palm. So people should learn from the mistakes what they are doing. So VFD is not the only solution. VFD brings also there are disadvantages. So here in industry, 25%, you see 95% are agriculture and building services pumps are used, and market share is all 64%. Lot of potential for saving. That's my point to say tell you. Okay, and life cycle costing we generally avoid in purchasing equipment, and that is a big problem. We see अभी कितना लगता है पैसा, कम लगा तो वही हमको परचेज करना है. ये thinking also in procurement department. But life cycle costing now it has become so much talked about subject that people in procurement, the good engineer now, all procurement people, and nowadays companies preferring not the materials management managers or GDMM कर लिया तो उसको material में no, engineering background with exposure of such things, all this understanding, they will be better procurement engineer. So while technically they'll discuss, and LCC cost, life cycle costing is important. This initial cost of purchasing is very less, initial cost. Installation commissioning later on. Then energy cost is 2. How much is the energy cost? Operation cost, operational cost by putting in power, other thing and all things. Then maintenance cost, CM. These 3 things are to be taken into consideration. These are to be considered how when you count is full life cycle concept. एक साल में 5 years के लिए आप सोच रहा है कोई भी इक्विपमेंट, 5 साल में आपको मेंटेनेंस कॉस्ट कितना होगा वो देखने का है. Not that he is giving warranty 1 year, 2 year and finish it. No, you have to take out the full life cycle cost. In that, as that is the thinking of the pump or any asset as such. If you only purchase your bike also like that. So in pump, there is a lot of savings, 60% savings, energy and maintenance possible, around 80-85% gear pump support. Pump cycle 75 HP, see operating cost 55%. Here, how best you operate the machine, and operating machine. Why I'm talking about reliability? What is reliability? Reliability from the operation, reliability from the maintenance is all about the reliability. Maintenance reliability is not going to help us. It is all about integrated system of approach. Integrated system of approach. Okay. Oh, okay. Reliability you have put on percent, or you have reliability manpower, right? But maintenance you have not done. It's not going to help. So it is all integrated system of presentation in integrated system of presentation of your maintenance and production team. Okay, so here in energy and maintenance, the main issue you can see life cycle cost. It takes care energy and maintenance more. So here we can save lot money. And let us take different type of design of the pumps. Pumps are different design: positive displacement, dynamic. These are not come simply. Over the time it is evolved. How it is evolved? Either maintenance has become easier, or cost of energy consumption become less, so energy savings, all the things has come into picture into design. So here is a flow creating device, different type, 2 types. Generally we divide in 2 types: PD and dynamic. We all know, whether it is in institute or industry, you all know. So these are the things. And energy, here is constant pressure. If we put generally positive displacement. Okay, for here in centrifugal we have a choice for pressure and flow. Okay, so that's the way we use dynamic pumps. Okay, so we, while putting the energy, you see less energy, more pumping we should get. So selection of the equipment should be like that also. Okay, so here in positive displacement pumps, if you see efficiency of the PD pumps around 98%, mechanical efficiency 90-95%. This mechanical efficiency can be increased 1%, 2% increase, lot of saving by maintenance, proper maintenance. So here in centrifugal pumps, energy consumption itself 75%. So that's why people are more talking on reliability and maintenance issues on centrifugal pumps. And here main issue is pump impeller, nozzle, impeller eye. These are 2-3 parts that should be taken into account in maintenance. Okay, so in centrifugal pump, how it works: impeller eye, water is coming in, apply low pressure, and you get more pressure while pulling out of the pump. Okay, so that an impeller vanes, it accelerates the fluids, and you get the higher velocity. And in the pump, in diffuser section, we get the more pressure. So that is the way in volute also call it diffuser. Okay, so this is the centrifugal pump, how it works, and this is the volute casing. And increasing area, what increasing area or increasing volume, you can say, is to the discharge. That is the impeller is moving. So this is the centrifugal pump in nutshell. 75% are used. So here energy management core principle is I told you it is all about our irregularity in performance. Means irregularity in its head and flow. Okay, that is the issue, and that is the issue means that takes care into science into this, and scientific solutions are possible by scientific consideration only. So scientific principle of fluid in motions are these all people have done for that. Okay, by knowledge, Newton, and all these people have done this. So we cannot have any solution as simple as that by any means without attacking to performance. Performance totally based on the scientific principle. So that's why core issue on energy saving in pump, compressor, anywhere is the equation of this equation. We are deviating from this equation while operating. And while operating, if you stick to this definition, best efficiency point, we'll never have a energy issue problem. Okay, and we always in engineering, if you take properly decision, take depending on the system cars at the curve in the field, we always will do better job in the manufacturing stage of the pump. So there are a number of efficiency, and there are these affinities law are available where by change of RPM, N is the RPM, and change of diameter, we get different type of flow, head, and power. And these are the things have to be taken into account. So energy saving, yes, it is all about hydraulic and fluid mechanics. Energy saving is nothing but purchasing some energy product or purchasing some VFD product and put it to the energy you'll sell. No, even if you put the VFD, people are not taking care of these things in an operation, will never get savings. And people will curse you. What happened? I'm not getting the things. I purchased all this. I've changed VFD. Why I'm not getting this? So that means we have to take care in the VFD. Driven machine is doing what? So driven machine has to do its job the way this formula demands. The formula demands. That's the thing. So this formula is like this. Displacement pump, it's a flow with coming like this, and centrifugal pump HQ curve is looking like this. And system curves, if you put either centrifugal pump or displacement, positive displacement pump for a particular system curve. What is system curve? कितना नीचे से पानी ऊपर लेना है, कितना दूर से पानी लेके आना है. These are our system resistance. The system resistance means साइट कंडीशन क्या है. तो वो साइट कंडीशन पाम्प का एक पुल है, पुल का वो बांध का ऊपर रख दिया, किसी ने नीचे एकदम पानी का सामने पंप रखता है. गांव में जमाने में हम लोग क्या करते थे, पंप को एकदम जितना नियर टू द वाटर पॉइंट लेके जाते हैं, सो दैट आवर हेड इज लेस देयर एंड मोर पंपिंग. If somebody is taking more height, it will not pump more. So things are there. HD and FD centrifugal pumps, different pump selections, and head and flow matters. And these two pumps has to encounter system curve. Now, system depending on the system curves and depending on the flow requirement and depending on the whole head requirement, you can choose which pump I will use it. Okay, so reciprocating pumps is very low head, high pressure, high head, low flow, high head के लिए है ना, low flow but high head, you can see like that. So system curve, these are called this is system curves. System curves looking into frictional loss and dynamic loss. Frictional loss means dynamics loss, and static loss. These two parts combined system curves. These system curves we get. I don't know how much time I get. Then we'll go. 11:30. Okay. So no problem. So here you can see efficiency point. Best efficiency point here. Somewhere where the HQ curve. This is head and this side Q. HQ curve mid system curve is the best efficiency point. Okay, so in details things are given here. I have put number of slides here just to make you understand, and those are very junior, not aware of it, they can get this lecture later on also, they can see, and that is the reason I have put all these things. And whatever I have told in the pumps class there, I have some of the things I have kept for them only. So here same thing is discussed here. Head, and Q, and over the time is going, the centrifugal pump it is going down, because more flow, head will be less in centrifugal. If you want more head, put positive displacement pump, not this. Okay, so like this, internal loss, external loss are there in valves, in pipes, in bend, there is external loss. Internal loss, internal friction of the fluid motion, fluid in motion. Okay, so head loss and system curves looks like this. So static head, characteristic of the specific installation. कितना ऊपर नीचे हमको हम पंप को फिट कर रहा है, इंस्टॉलेशन कर रहा है, इज द स्टैटिक हेड. एंड फ्रिक्शन हेड, डायनामिक लॉस, इंटरनल द internal the pipes. Okay, dynamic loss, and that gives us this type of curve. As this is the system static head, how much height it is, and after that this is friction, dynamic head. Okay, so these are dynamic head. Here static head is very less, dynamic is more. The different way of encountering in energy savings, both. Okay, so head and capacity, pressure head. If you change the pressure head, if you want to have a change in pressure head, you change diameter, number of impellers, size, shaft speed, you can change it. So you can change it, and that's what it is. It is good. We do not to change. We select a pump such a way we don't want to change afterwards. That's good engineering. When we are not able to good engineering or foresee our future requirement, but it is very bad for a plant. Today they're installing a machine, and within 2 years, 3 years, they want to go for VFT. It is not a good engineering, I say, because either you have not visualized what is requirement after 2 years, 3 years. Excuse me. So that is not wanted actually, but things are happening. They want energy conservation immediate, they have to reduce. Somehow they purchase the plant, prove the plant, immediate करना है, जल्दी करना है करके कर दिया. So that is not the solution. Okay, we have to do it, even late हो गया. But in that case, you can do pressure head by all these things. Capacity, exit width with the exit width of the impeller determined by capacity. Capacity is determined by that. So the more water pump, more energy also required. This is the element of a pump curve. This is the efficiency point, best efficiency point, and these are the maximum diameter. This is the minimum diameter. Okay, this much diameter with this efficiency. Suppose this is the best maximum efficiency point is this specific due to point. Efficiency point is this, line this. So this is preferred operating range is this. We cannot go any efficiency zone. Then again it will be energy issue. So we have to think about that, which is the minimum diameter I'll keep, because this power scale, you can see power almost same is going on. So I must get maximum power, a maximum efficiency with the minimum power. This is the power. And NPCH, this is the curve. Net positive suction head, we'll discuss a little bit later. So these are the different head curve, head and capacity curve, HQ curve, which I was telling you. This is the efficiency point, efficiency curve. This is the head capacity. This is a brake horsepower, increasing over the capacity, and here brake even best efficiency point. This is the point, best way it will run. Efficiency is maximum, and HQ more or less anywhere side you go, you are compromising the saving in energy. Okay, because this energy curve is there. If you go here, energy is more, but your power pressure requirement less. If you want more pressure, energy less, but your flow will be low. So all judicious judgment should be done. Impeller diameter, how it change over the time in efficiency is shown in this graph. Okay, and that means energy saving pumps, there are a lot of possibility. Maintenance and monitoring opportunity, controlling systems, operation, flow demand, design pumps, other efficiency, proper sizing of pumps, of all the things. If it is shipped, we have to proper size. That time it will come to the maintenance only. Okay, otherwise it is good if let take care by engineering group, and they give me an equipment which will have energy efficient. So parallel pumping, other things, these all maintenance issues and operational issues, impeller trimming, other thing, velocity, all the things where you can energy save in the pumps. with clarity on performance curve, now we can appreciate and grip on energy saving. With no clarity on performance curve means no clarity on scientific principles, mean total disregard to our all and scientific principle, we cannot save energy by whatever means way. No sir, वो तो देखता है ना, जब हम VFD लिया हो तो taken care of. No, those people are much educated. Maybe somebody operating there in the field not so educated, he will be running in as per his own way. valve control करो, ये करो, वो करो. VFD लेने के बाद भी अगर आप valve change and reduction and control valve use करते तो क्या मतलब है? So all the things come into picture. So energy saving, there is a lot of link. Pumps we specify is important, and what is the system requirement is the important for the better efficiency. So these are the most inefficient way. Either flow control takes out our inefficiency, takes out our efficiency, or pumps we specify is not at the requirement, system requirement. So this is the problem. And pump in parallel, you can see pump in parallel. When you want more flow, put more parallel pumps. But we will compromise certain flow, and certain flow we have to compromise, because if you put two pumps, almost double here, parallel system, two pumps. This is the parallel system curve. H over H versus Q. This is parallel system curve. The two pumps, 1 and 2, one pump is only here. This is the single pump. This is two pumps parallel. The two pumps parallel, you will see double flow. But in practice, you won't get it. You will get, because you have to encounter system site condition क्या है? वो site condition का कर्व है A, system कर्व. तो system कर्व हम ऐसा जाके ऐसा नहीं कर रहे. We are not doing like this. System curve is same for the particular installation, but I have put two pumps. Okay, right? So two pumps, intention is double flow. We'll get double flow. वो सोच के लगा दिया, but in practice you never get double flow. Be careful, never be, because here system curve will determine how much more you'll get. Will get जो एक पार्ट में मिलता था उससे थोड़ा ज्यादा मिलेगा. So in between maybe half, you can say half. So double नहीं है, 1.5 times मिलेगा flow. In series is different. In series, what happened? In series, adding their head. So when you pump water from some dam here in Mumbai and get it to Panvel, from Panvel another pump, another series, again means you want to keep the pressure head intact. So more pressure head, number of series connection you can do it. And in that, we are thinking about head increase, not the flow. Okay, so flow will be same, but we are increasing the head. So in two pumps, actually supposed to be 1 and 2 double, but you will not get double head. You will get less head because it will come to the 3 point, because it has to encounter system curve. So it will come to the 3 point. So ultimately, even more number of pumps, you will get the pressure up to here, not this. This is all about parallel series operation. And how we operate for same system efficiency, or what is efficiency, system efficiency, पैसा कहाँ से जाएगा? Maximum to energy. So you think it about that way. So parallel operation 2, and you can put 2, 3, 4, 5, but it will look like that. System is 1. You put any number, you can see how much gain you are getting by in the flow. You will not get 2 times, 3 times, 4 times. You will not get, because your system curve is not changing. Your system resistance side condition is not changing. Right? That is the bit. This is all about in speed variation, how it takes care of speed variation. In for simple way, I'll show you the next slide. Okay, otherwise it will take time. So in speed variation, when you throttle, when you want to have a less energy with throttle, okay, or reduce flow. In that, what happened? From A point, it will go to the B point, and this system curve, which is 82% efficiency, it will go to the less efficiency, but you want flow less, 300, from 500 to 300 flow. 500 का pump है, but you want 2 साल के बाद हमको 300 क्यूबिक मीटर पर आवर लेना है, बिकॉज हमको प्रोसेस जो है वो प्रोसेस को उतना ही रिक्वायरमेंट है, ऑपरेशन पेपर बोलता है उतना चाहिए. तो हमको क्या करना है, हम थ्रोटलिंग करते हैं. So throttling करने में क्या प्रॉब्लम है? We are increasing the system resistance, and increasing the system resistance means you are increasing the frictional head more. This is the red curve. Okay, and static head remains same. जितना हाइट में है बस खत्म, उसमें कुछ हम कुछ लेना देना नहीं है. So system carb is increasing, and in that case A is supposed to be, and its system carb, it cannot go through this system carb, because if this system carb has to flow, we cannot change the flow. Flow will be here only. We want to less flow, so flow will go here. So flow will be 300 here in this point, and here in this point your system carb has been changed to this red line, and means what? You have gone against high pressure and you are losing so much energy more. Instead of doing more energy to this by throttling, put RPM less, because here this is the constant speed. Speed VFD, which you are talking about, VFD speed, and if we put VFD in lower speed, we get this carb, blue carb, and blue carb satisfy my system carb which is available at the site, right? So our intention of 500 to 300 cubic meter per hour is satisfied with less energy. I think it is everything clear now. So speed control is better than throttling always. Okay, that's what. Okay, because you have to keep, you see, system carb is bottom one, it has to flow like this. In an example, if you shift, what happened with the new point, it is coming 80 to 77%, and 300, you can see here it is, you have to encounter 42 mm head. Okay, here it is 82%, 70% efficiency point, and at 70 mm meter head, 70 meter head is 70 meter head, and here it is 42 meter head. If you go to the VFD, 42 meter head, so your head is reduced, means you are not using more pressure, but your pressure is not, maybe your process is dissatisfied, but your more important, your flow is satisfied requirement. And same thing explained here only. In, you can see 100 HP valve control, 15 HP lost, which is zero here, So here 75 HP motor will take care my efficiency requirement for the process operation, while consuming 15 HP less, and 15 HP kilowatt hour kariye, and number of month year and kariye आप कितना huge amount. And this is not the only pump, there may be many pumps like that, So pumps and energy saving, now we understand by using VFD we can just put this carb dotted line up down. Okay, up down. So more than VFD, this is the best efficiency point, the blue, this is the blue one, and more up down depending on the, if you want to put little bit more energy, but you have to put the flow higher requirement, you can always play with this. So that is the things he describes here. So in affinities law, nothing means how much affinity between the parameters. It is all about affinities law, and affinity law we are trying to explain in unit level. Affinities law, you trying to explain what will be our flow, head, and power requirement when you change the RPM. So whatever thinking in the VFD, you cannot do whatever you feel like. This is controlled by this formula. RPM will be changed. You can change. This is the way. Little RPM change, your power requirement will be 8 times. Can you see this here? Cubic. This is formula is cubic. Scientific principle. So scientific principle will not allow you. This will be 8 times increase. So double the speed, power will be 8. So we cannot play whatever you feel like. We have to have full idea on this. And person who are in the field, they are very much aware of it. Engineer job, this, not the technician. Sometimes they don't bother. Engineer has to look into all the parameters. And good engineer of today, they are very much smart. They are from the place and they are attending lectures like this all over. They are going to industry. They always take care, sir, a problem ho raha hai. Dekhiye na, this is the issue, this is the formula. Then they will be appreciated also by the management. So you should think about that. And if you change diameter change of the pump, impeller diameter change, how it affects. Diameter change also equally horsepower like this. So we cannot see whatever you feel like. So little bit diameter change, power will be very less. 8 times it will be less. So if you increase the diameter, more. If you decrease diameter, your power will be less. So that way it is done. And impeller trimming effect is in the industry very rampant, and people are doing very easy. You have purchased a impeller 500 mm or a 500 mm, and you want to make it to some 400 mm, and within the requirement of the flow requirement, then you can do impeller trimming, which is very important, which is very important by changing the impeller. Okay, so that is frequently done, and I have cases also here. I'll show you. By changing impeller, you get the car from the beginning to here, but you can see you are encountering same system car, not an issue. And after trimming, you get the reduced flow which you want, the desired flow. Okay, after trimming always about you want to have desired flow, but how easily I can get instead of changing the pump itself. So that's why people they want this. So this is done by trimming. So energy saving by trimming impeller. This is the case called condensate pump in a refinery in Gujarat. So they have done it. Initially, they purchased 550 millimeter diameter impeller and rated power of 160. And this 160 power with RPM 480, they need 100 or something. The refinery and the commission, they thought of this, but over the time they thought, no, this is not required. And costing and cost benefit analysis is showing the pump is showing more, purchasing a new one. Somebody raised hand, Mr. Sujit Kumar. Please tell if there is any question at the end. Sir, Sujit sir, please, what is the problem? Is he YouTube or with us now? Okay, I don't know why he raised question here. A question he has put a raised hand, whatever. So see, they want that from 350 cubic meter per hour to he want around 100 cubic meter per hour. Okay, so they've done trimming 500 to 470 trimming, and 10 to you cannot trim as much as you can in impeller. Then entire function and geometry, everything will be lost, and it will encounter a problem to the formula. So without going deep into this normal understanding that you cannot go more than 10 to 20% of the diameter reduction. Okay, so that is taken care. They've taken around 15 cubic meter per hour. Sorry, 15% reduction in the impeller dia. Okay, so energy saving in that process, the initial design was this, current working parameter is this, and current working parameter they're already getting less kilowatt, because 141 and on kilowatt here 99.8 kilometer, and current working pressure is this. Now they have gone into, and as per current working condition, power saving they're getting 53, but here they have done it by impeller dia changing to how much? Impeller dia changing to 470, and they got saving around 2.5. The rate unit rate is 2.5, and they get total cost of saving 13 lakhs per annum impeller. It is running. They're getting every year 13 lakhs. Because if they would run this in this diameter, then they would have lost this. Okay, this is a refinery case. I cannot tell the company name or things. So specific speed is another concept of the pump, by which once you purchase a pump, you direct take the specification. Depending on the flow requirement, you can get different type of pump. So you need to go for detailed analysis. Once you get a specific speed, and you can get the pump from the manufacturer accordingly. So here in the actually these are geometrically similar, different sizes of pumps, geometrically similar. But if you tell the definition, unit volume, unit time, and unit head, there's nothing but you put one in this formula, and you get a specific. Everything one means one. That's all. So we get specific speed like that. Okay. So in specific, we also affect the shape of the HQ car. That we have a separate performance car study on specific understanding. These are the dynamic elements, not necessarily identical. So specific speed, why we want? Because different size pumps, how will fix? If specific speed 200, will go around Francis. If specific speed around 1000 or so, just go with this, and geometrically similar pump he will give you for a particular flow on this radial vein. If higher specific speed, then axial flow type they will specify. So this is the understanding. The speed of pump independent of its size, so we have a specific speed, and formula takes care of it. So in system curve, that already I have told you, these are the two things. System curve. This part. If this curve, system curve, sorry, this system curve, head Q curve, system curve is also head Q curve.
ते 1 वाला बघ, 1 ते 2 वाला मोबाईल वरती बघ.
Mute yourself. System head capacity curve. This system head capacity curve would have started from here 0 if no static head. Means यहाँ पे पानी है, पानी के पास ही हमारा पंप है. System head 0, static head 0, right? If you take the fluid pump, water. So the water. So near to that. So if there is height, then static head come into picture, and these are the dynamic loss. That's why you get system curve. And this point is the operating point based of the efficiency point. So like this, most efficient in this pumping system, most efficient is the pump. Most inefficient is the pump itself, because it is mechanical part. That's why more inefficient. Other hydraulic, static head, other things, if you taken care properly, that is the more least efficient is the pump itself. So that's why we get hydraulic power always higher than the shaft power. Shaft power is always higher than the pump itself efficiency. So that if you take into account, this is the electrical input will be much higher than the shaft power, and shaft power will be much higher than the hydraulic power. So I don't know whether I have told correct way in the previous minute or not. Okay, so hydraulic power and shaft power, that's why efficiency come into picture. And in this efficiency picture, we put electricity, suppose 100 kilowatt, we get shaft power maybe 95, and accordingly hydraulic power flow, which is our efficiency point, flow, we get much less than that. That's the idea. So all these things at efficiency point 60%. If this is the efficiency points, this is the best efficiency point 60%. You go any side, there will be efficiency loss. And in the efficiency loss, if you take 60% efficiency, hydraulic power Q head rho G divided by 1000, which gives around 9 kilowatt. Shaft power will be around 15 kilowatt machine driver you require. In drive you get 15 kilowatt, but motor power require 16 kilowatt, because everywhere there is a input output too much difference, whatever difference. Okay, so that's why efficiency, and that's why motor power is much higher. For a 9 kilowatt you need a 16 kilowatt motor with the efficiency 60%, and efficiency 50%, it is much more higher. It comes around 31 kilowatt. So instead of 16 kilowatt machine, we get instead of 16 kilowatt, we get 13 kilowatt. For 50%, we have to put a motor higher capacity, and loss. Higher capacity means loss. So we have to take care of the pump efficiency, and that is the things you have to understand the case. In cavitation, we get a lot of cavitation, in the pumps. And that day, somebody asking me, sir, can we prevent cavitation? It is possible to prevent cavitation if you maintain it properly, operate it properly. So there is always possibility. So absolute pressure at the inlet. See, this is all the definition about the cavitation. No cavitation means vapor pressure must be less than suction inlet pressure, and must be less than atmospheric pressure. That is the thing. And in this, these are the causes different. It can damage the entire pump internal blades, everything, and it should be always availability should be higher than the required. So pump inlet, whatever required here, it should be higher than the internal. That means whatever required here must be available at the atmosphere, and it should not go down to the vapor. If vapor here, then that will be bubbles form. And if it is bubble, then it is implode, not it implode. That bubble will break. That is called implosion. Okay, okay. Cavitation bubble implode, and because of this collapse. Because of this, it will increase, then collapse. Okay, so in that case, lot of energy, and how this energy will go, it will impact to these blades, and it will आस्ते 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 erode हो जाएगा over the time, and it is so high. It is, हम लोग क्या सोचते हैं पानी जा रहा है क्या प्रॉब्लम है, but if it is going, it is going to the vapor pressure, means it is heating. It is heater. It is not a pump. It is becoming like heater. So it is spoiling the entire such a velocity. So that is the problem of cavitation. And this all the formula takes care Bernoulli equation and how it will become, and all this Bernoulli equation is applicable to this. Ultimate aim is available suction head. I'm not going to discuss here because we are not discussing only pump, so we will not go details. But you see, if cavitation pressure carry on decreasing, vapor pressure carry on decreasing, then your temperature is increasing. 36 to 36 temperature, can you touch it? Okay, so you can touch, but 36 temperature you cannot go around Mumbai, so much hot. So 36 temperature like this, if change in pressure impact water temperature, and that is cavitation creation, and this cavitation creation is here and nearby. So we have to take care the inlet pressure is never always high than your vapor pressure. So vapor pressure should not go down like this. That's the formula tells about it. Okay, so in a nutshell, this is a characteristic system design. This availability of the machine, system of design कर रहा है, तो availability उतना होना चाहिए. And availability requirement is a pump design. System of design में site condition जो हम सोच रहे हैं जिसके लिए pump, that is availability. हमारा प्रेशर कहाँ से पानी लेने का है, ड्राम, कूलिंग वाटर टैंक्स कहाँ से लेना है पानी, उसका हाइट क्या है, ऑल द कैलकुलेशन टू बी डन. तो सिस्टम डिजाइन, सो मतलब एंटायर पाइपिंग सिस्टम डिजाइन के टाइम जरूरत पड़ता है. आई रिक्वायर दैट पंप मैन्युफैक्चरर ही टेक्स केयर डिजाइन स्टेज, इंजीनियरिंग स्टेज. ओके, सो दैट इज द थिंग. सो अवेलेबिलिटी शुड बी ग्रेटर देन requirement to avoid cavitation, right? To avoid cavitation, this is the cavitation line. So avoid cavitation, it should be up, and whenever it is less than that, it will go down the cavitation bubble formation, and it will create, and what is affect, it will affect the entire efficiency, and it takes care of energy also. Total energy also will be more. You are pumping less. लो पानी नहीं है बट पंप चल रहा है, and it is like a heater working. So avoiding oversizing of pumps, that we have told, oversize that we have already discussed in 500 cubic meter and 300 cubic meter previous example. Here we should not take oversized pump. That is the idea I already explained previously. Okay, so in energy saving in a power plant energy area, there is a number of stages they have taken a view, and a lot of problem was there in this pump, 860 kilowatt. Okay, the requirement is 50%. Can you imagine? Requirement is 50%. Can you start a machine like this? That means there is an engineering issue. I'm not telling wrong way to say somebody is capable, but we should think that we want 50% partial load, but you want a pump like, means total decision was wrong. But machine एक बार आ गया तो क्या हो गया, promoter we have to run the factory, right? So they initially put a VFD. So VFD is not the solution everywhere. There may be many other problems, electro discharge machining of the bearing, many other issues. So there are problem in the vibration of this pump. When they are going to lower the speed, it is matching with the resonance frequency, means natural frequency of the structure. Okay, every structure piping will have natural frequency. The suction side, discharge side, whatever it may be. So they were again changed to different stage pump, from 6 stage to 5 stage pump. And the 5 stage pump also there is a problem. So accordingly they some changes in the structural plates and other things and material, all the things they've done it. So the different case, 2-3 stages they got the benefit. and that benefit was 275 kilowatt. This benefit as the cost of, in a lighter side, is the cost of not selecting the right pump initially. So nothing to blame. They're getting right now this much less. Otherwise, they will use this machine, and this machine will create so much energy, 50%, more than 50% energy loss. So they've got this gain. So reduction in power. This is good exercise, understanding the things, understanding the physics behind it, and all the things are understood. Fluid mechanics understood. People have done this job, got the benefit. But my point is different. My point is this: we should think reliability maintenance issue beginning from the design. Beginning means I am talking about the academic institution. Those are giving knowledge to the student, faculty, junior faculty. They should get the things over, along with the industry, that such things come should be taken care of in engineering, research and development stage. Okay, so then to my point, in that sense, that most energy saving opportunity and brains are available in academic institution, whether IIT, NIT, government institute, private institute, wherever they're thinking of a pump or any assets maintenance and energy saving issues. That's the point. We should be serious in thinking while transferring our knowledge to the student. And I always tell to students or whoever is listening that we are all from the borrowed knowledge. We are taking from somewhere and delivering to somebody. That's all our job. When we are doing something great or something extraordinarily new thing or breakthrough research, something, we will be recognized internationally, because science cannot be wrong. So internationally, in that case, what I am thinking, that we are all, there is no ego in this, because we are all in the same subject. Either you are teaching now, I am telling you, somebody taught you, or you leave the institution, somebody else will teach you, but nothing else different. Okay, so all are borrowed knowledge. So nothing ego in it. We should share our knowledge that way and get the things done. And academic institution is taking great role in this. Not that it is just for saying. It is actually. It is, because that's the thing. But people in industry, we have to tell them that you do something, we do something, there is a different theory and a practical, then become a problem. Because theory and practical, sooner you start differentiating, there won't be solution. Jugal bugal kuch nahi hota. All has to come as scientific principle and scientific way of solution hoga. Okay, so people think in industry, academic institution वो तो पढ़ाता ही रहता है, teaching करता है, उसको क्या मालूम है. Or academic institution thinking, no sir, we need some practical exposure. Why? What is laboratory in this? Laboratory, there is a pump, you are taking all those things. What is different in that? If there is a difference, study that difference. There cannot be a difference in the scientific principle, and same person who is maintaining a small machine or large machine, philosophy is same maintenance, tool same time, it is following all performance curve. What is the difference you will do in the maintenance? So we should not feel afraid of the things and should not take the subject that way. Okay, in such any subject, not only energy saving or pump or whatever here. So, oh shit. So this is the pump they were talking, and they got the saving like this. Saving is too much, 72 lakhs per year. For industry, 72 lakhs per year, when they have to run like this continuously. Not that हमारा सोसाइटी का एक पंप खराब हो गया 10 दिन के बाद और किसी को बुला के कर लूंगा, ऐसा नहीं है. अभी आज के पंप ठीक है, और sometimes full day you cannot wait for the pump to open, start. So here savings is lot, energy intensive industry. In that case, sir, can I take up to 12:30 and finish? Hello, sir. Hello. Are you getting me?
Yes, sir.
Can I take up to 12:30 because you have lost?
We have to wind up. We have to wind up, sir, in 10. Hello, sir. I'm Professor N.K. Deshmukh.
Yeah.
We have to wind up in next 10 minutes because after that second session will be start by 1 p.m. So please, sir.
Okay.
We request you to wind up in next 10 to 15 minutes.
Okay. So I not go any much details now. And maintenance, you know, there are so many maintenance possibilities, and a lot of BFD you can use. Okay, soft food has a lot of energy. If you cannot maintain proper soft food, then there will be energy issue. And coupling alignment, every alignment is got a problem, and alignment has got energy saving. And in that alignment, misalignment, different type of misalignment. In that misalignment, we get 1 to 10% less consumption if properly misaligned. And this is there are studies are available. If 1 mm offset of a machine, offset means parallel misalignment, then you get this much power loss. So there are cases available on different alignment in 0.01, 0.02 mm, depending on the machine. Its limit. Okay, unbalance create lot of unwanted force on the shaft, and it takes a lot of energy. Okay, there are studies available, and that's why I want to precisely balance the compressor. One of the best severity of the issue of the compressor is 88% of the cost goes just production of 50% and leakage 25-30%. And in this production, we use only 5 to 10% at the end of the user. Okay, so there is a lot of leakage, there is a lot of severity issue in this. And we know 6 mm aperture leaks any compression system, okay, is 5 lakhs per annum. 5 lakhs per annum. There are things available in books, in Bureau of Energy Efficiency, and there are things that are available. We can look into that. So much energy, but we very less care on energy saving in compression, which is the most wide scope in the energy saving in the compressor. Compressor and severity of the issue is very much. We get only 5 to 10%. So we have to awareness is issue, big issue, awareness. Leakage is too much. Nobody bother about the leakage, and leakage is not visible as long as it is not giving a lot of sound. People don't care about it. Forget about the equipment reliability. Okay, so survival kit is operation, how we maintain it, adapt latest technology in maintenance, and we have to meet carbon footprints 2030 goal for the energy, and international certifications are required, and inspection repairs are important. So past, present, future, how we do it? Over the time, people used from recip to has come to turbo compressor. However, there is less innovative things are available in the maintenance solution, smart sensing, other things, and no points of intervention. Where are the points where there is energy loss? Energy loss. All the points are to be monitored regularly. Okay, all the points. Okay. How to go about? We go either in maintenance practices or operational issues or maintenance installation aspect. Installation aspects, it can be 25 to 30% if you properly maintenance sorry, it is not installation, it is inspections. Sorry, leaks in the itself 25 to 30%. I'll change it afterwards. Okay, so this is the how do you go about system approach to saving compression loss. So in the system approach, again PV diagram and failures and fault, we have to maintain this, and we can get the analysis done by external agency or people are there who can do this PV diagram, and we can get how whether it is a compression or suction, or if there are problems in the PV curve. Accordingly, we can get it. So performance curve should be that it should not go beyond surge limit, and it should not go above stone walling. Okay, there's a different thing. Who knows compression system, anti-surge system, they are aware of this surge limit here and stone wall. We have to run this machine within this performance curve. I not go detail into this because no time now. Not operating close to the BEP is a main problem. Either near to the surge point, we have to avoid. That's why generally common procedure derating of the compressor is done. It is more simplified way. This is surge line, performance curve. Okay, so this is the something potential possible. And performance monitoring and health monitoring of the centrifugal compressor. There is online systems and online data is available, online knowledge available, and highly sophisticated maintenance systems are available. Okay, so need to respond to the system. How systems will respond. Accordingly, we have to respond also from the system when to take care that centrifugal compressor is going out of surge line and going out of stone walling. Okay. Okay, so that is the things you have to look into in maintenance. So the simple diagram of anti-surge systems. Okay, I don't go details into this. And everywhere possible, generation, transportation, distribution, everywhere we can get energy saving. Okay, generation also of the compression, transportation, distribution, everywhere it is possible. So there is a predictive systems available, the protective systems available, things are available. We have discussed that card, ultrasonic testings at different places with meter, and we can get what are the points of turbulence and energy loss. Then we can get the how much energy it can be calculated. Okay, so there is a calculation here, CF loss and different kilowatt savings per hour is given by fixing leaks. So leak detection, maintenance of this which is given. So here there is a compression steel plant. There also, I don't want to go into more, it is there in this, whoever is looking or may see the chapter. Now I want to, with this I want to conclude here. Summary takeaway is this: it is all about awareness. Energy saving in maintenance is all about awareness. See, it is all about awareness. If we are keeping our energy and thought process to be on, and we have to think that lost every minute in operating and maintenance asset is huge. It's huge. You have seen in the compression loss and leakage. Okay, and change of thought process. So far we are thinking energy means wherever there is a high temperature, energy is lost. No, we have to go to the cold zone. Our thought process has to go to the cold zone. Cold zone means maintaining. Where are the maintenance is wrong? Where are the operational wrong? Cold zone. So our thought process, let's shift it from heat zone to cold zone. Okay, so that's my point. I have just put it here for heat zone process. And indices, we are so much prevailing indices in all of our industry right now. We are thinking reliability center maintenance, total productive maintenance, preventive maintenance, predictive maintenance, asset performance management, asset integrity management, asset life assessment, all the things you are doing in maintaining the asset one way or the other, partially they're doing all the things for energy saving. But we need to think now in different way: energy efficient maintenance, energy center maintenance, total energy efficient maintenance, or energy efficient design, energy efficient way we have to think it about. Even TPM, energy OE, is the energy oriented thinking for availability, performance, quality issues. Energy OE you are thinking, so energy OE or total productive, productive, total productive efficient or productive energy management, that way maintenance, total productive energy maintenance, that way. So we have to think our thought process has to change. With this, I conclude here. Thank you very much for your virtual time. Thank you.
Hello. Thank you, sir. Thank you, sir. Indeed, it was a session filled with knowledge. Now, with your permission, I would like to begin the question answer session, sir. Should we begin, sir, question answer session?
Let's go
now,
ahead.
I request Professor Ratnam Gujar to start question answer session. Over to Ratnam Gujar, madam.
Good afternoon, sir. The first question is by Professor Rehan Siddiqui. It is, what are the latest energy maintenance technologies available?
Latest
energy maintenance technologies available.
That's why I told you energy maintenance, it use predictive maintenance technology for identifying the different abnormality in the system. Like your different predictive technology means condition monitoring technology I was discussing. Okay, that is for maintenance side I'm talking. Don't think other three. Maintenance side, energy efficient is huge vibration monitoring system, huge leak detection ultrasonic system to leakage detection of the air compressor. Okay, huge NDT method, different NDT method available in this for static structure and all this. So those things will help you to identify all in time where is the wrong, where is the problems. So once problem is understood, we can repair there. Sometimes in the electric arc furnace or somewhere reformer thing, we don't know which is the hot spot. So thermal imaging is done there. So once you get the thermal image, 300 inside 1500, external temperature come at 300, so require 75 or 80. So you understand what is the delta T. Once you get the delta T, we are all engineered to calculate energy loss, right?
Thank you, sir. So second question is by Professor Parmeshwar Kaur. How can we prevent breakdown? Are there any methods, latest technology available to prevent breakdown, and is thermal imaging can predict the breakdown?
That's why I think if he has attended my this session. I have told thermal imaging. Just a minute, I take. Can you see my screen, or I have just left it?
No, sir. Screen is not visible yet.
Not visible?
Not visible yet.
Just a minute. Can you see thermal image of this?
Yes, sir.
See, this is the spot. This is the very latest. How much? 1410, my dear. This is October.
Yes.
1410. This is suppose you don't attend it. What will happen? First of all, there will be reliability issue of this plant itself. Then thermal imaging, you can find out from our delta T before and after, and if it is happening, you can find out. No problem. Like this, many every day people are, there's nowadays plenty different application available, plenty all over in India, near to Mumbai, where you want to go and see, come, we can show you, no problem. All the substation, all the problem, the widely used thermal imaging. And nowadays thermal imaging, every Indian aware of it because of Corona. Every airport has got thermal imaging. What is 37 degree? Okay, go. If it's 39, 40 degree, you'll be captured and kept into the, okay, he has got Corona or something else. So things are available very widely. People are using it online also using. Okay. So things are available. Things are available. Sorry. I have shared it or not? Can you see this?
Yes, sir. Yes, sir. I can see that.
Okay. So things are available, not an issue. Please go ahead.
Okay, sir. Third question is by me only. Can we develop AI software for condition monitoring for predictions?
It is available. People are doing. Please see how people are doing algorithms, different machine learning and IoT platform. How they are using this tool, predictive analytics, and for the predictive maintenance. These are all predictive maintenance. You predict something, then you maintain, or it is called condition monitoring condition of the assets, or we call it diagnostic engineering. So once you these things are available, you can definitely do. We will be happy to. I can tell to collab with some researcher on this line, and you can do some study on that. Not a problem.
Yes.
Plenty available. Not a problem. These are the first time you are listening, but it is our last 10-15 years we are nurturing these things.
Yes, sir.
Okay, do some project thesis on this.
Okay, sir, definitely. Thank you so much, sir. So I conclude our question answer session. Over to you, Deshmukh, sir.
Thank you, sir. Thank you. I think all participants are satisfied with the question and answer session, and whatever the doubt they have got the answer of their doubts. Now I request Professor Mukund Walse to propose vote of thanks and conclude the session. Over to Mukund Walse, sir.
Hello. It is a privilege to propose a vote of thanks on this occasion. I, Professor Mukund Walse, on behalf of MCT's Rajiv Gandhi Institute of Technology, Department of Mechanical Engineering, and on behalf of Organizing Committee of AICT AQIS sponsored online 1-week short-term training program, Phase 2, on recent trends in energy management and audit, and my own behalf, extend a very hearty vote of thanks to Dr. PYNE for accepting our invitation as a resource person and sparing his valuable time with us. He has given a good insight on the topic of introduction to the topic, assets and energy consumption in industrial assets, energy links with the operation and maintenance, evaluation of maintenance, pumps and energy thoughts in design, and energy saving in pumps. Thank you so much for your valuable guidance, sir.
Thank you. Welcome.
Today on 23rd November afternoon at 1 p.m. we have the second session by Dr. Sandeep Doshi, sir, on the topic renewable energy. Thank you so much, sir.
Thank you, sir, for joining. Now here we conclude the session, and thank you very much for joining all participants. Thank you so much for joining today's session, and we'll again meet at 1 p.m. for Professor S.N. Joshi sir's session. Thank you very much.
I request the technical team